Hi guys, tonight we're going to talk about, continue with our transformation of functions. Last week we were looking at how to move a function horizontally and how to move a function vertically. And tonight we're going to talk about how to stretch a function vertically and how to shrink a function vertically. So let's go ahead and get started. Okay, we're going to review what we know from last week. So we're going to use this set of points here, these characteristic points, negative 6, 3, 0, 9, 2, 0, and 8, 6. And what would the new characteristic points be if we applied this type, in this case it's a translation. And we know it's a translation, and we know it's going to be a translation horizontally because it is inside the parentheses. So this translation of plus 2 is going to give us, we are going to translate our function 2 units left. And remember that a horizontal translation is backwards from what we remember. So this means, or from what we would think. So this means that we are going to be subtracting 2 from each of the x coordinates. That would give us, so if we subtract 2 from negative 6, we get negative 8, the y coordinate stays the same. Subtract 2 from 0, we get negative 2, the y coordinate stays the same. Subtract 2 from 2, we get 0, and again, the y coordinate stays the same. And subtract 2 from 8, we get 6, and the y coordinate stays the same. So if we were to graph p of x and p of x plus 2, it would shift 2 units to the left. So let's go ahead and look at what happens if the shift or the translation is not inside the parentheses, like in number 2. This transformation or translation affects the y values. Our first one affected the x values. So this means it is going to be 11 units down. And that means we are going to subtract 11 from, in this case, the y value. Our range is going to change. So our x will stay the same. And then 3 minus 11 is negative 8. Second point, x stays the same. 9 minus 11 is negative 2. We're going to subtract 11 from the y value here, and we get 2, negative 11. And then for our last one, we get 8, negative 5. And again, this should be a review of what we did last week. Now here's where there's a little bit of change. If you look at these next 3 functions, negative p of x, p of negative x, 10p of x, and 1/3 p of x, and I'm just going to take that 1/3, that negative sign off that real quick, and we'll do another example on the bottom. We'll take that one off. What do these types of transformations do? So think back to the last unit. We had reflections and we had dilations. So for this next example, and we'll explore this more in class, the negative in front of the function is going to reflect over the x-axis. So that negative right there will reflect this function over the x-axis. And what that means is that it becomes our x value stays the same, and we get negative y. So going back up here to our function, negative 6, negative 3, our x value is going to stay the same, and our y value becomes the opposite. So we end up with negative 6, negative 3. The second one will be 0, negative 9. Remember, it's x, negative y. So in 2, 0, the x stays the same, and negative 0 is the same thing as 0. And finally, we have 8 and negative 6. So this transformation will reflect it over the x-axis. So if we look at example number 4, this time it's p of negative x. So if the negative out in front of the function reflected over the x-axis, p of negative x is going to reflect over the y-axis. And that means negative x and then y. So head back up to our characteristic points. -6 is 6, and the y stays the same. 0 and 9 will also remain the same because a -0 is just a 0. The opposite of +2 is -2, y stays the same, and then -8, 6. So let's just go back and recap for just a second. An x plus 2 means a shift of 2 units to the left. If it's inside the parentheses, -11 is going to affect our range, so our range was decreasing by 11. A negative in front of the function, here we go, a negative in front of the function is reflection over the x-axis, so our x values stay the same and our y's become opposite. And then p of -x will reflect it over the y-axis. X becomes negative, y, or x becomes the opposite and y becomes the same. So just real quick, now we're multiplying 10 times p of x. So if we're multiplying 10 and p of x is equal to y, then we're multiplying 10 times the range. So this is going to increase the distance from our x-axis. It's going to give us a vertical stretch of 3. And we're going to multiply the y-coordinates by 3 because it's giving us a vertical stretch. And p of x, remember, is the same thing as y. So really we're just doing 10y. So this one, and again we'll practice this in more class tomorrow, the 10 right here means that we're going to multiply the y-coordinate by 10, and it's going to give us a vertical stretch. So it's going to give us a stretch up and down. So if we multiply all our y-coordinates by 10, going back to our characteristic points again, we are going to get the x stays the same. We get -630. X stays the same. We get 090. 2, 0, because 0 times 10 is 0. And then finally, we get 8 and 60. That is going to give us the vertical stretch that I was talking about. And that just means that the distance from the x-axis has been increased by 10. And that's our vertical stretch. So if our number, just like a scale factor, if our number is greater than 1, we're going to get a stretch. If our number is less than 1 and bigger than 0, like 1/3, we are going to get a compression. So it's going to kind of just compress together. It's going to get smaller. So the distance from the x-axis will decrease. So we're going to do the same thing we did up here. We're going to multiply the y-coordinate by 1/3, and that's going to give us a compression. So in this case, it's going to be compressed. It's going to get smaller. So instead of getting bigger, it's going to get smaller. The distance away from the x-axis is going to decrease. So we are going to take all of our y-coordinates and we are going to multiply those by 1/3. So again, x is staying the same, and then 3 times 1/3 is 1. So for the point 0.9, we get a vertical compression, and again, sorry about that. 9 times 1/3 is 3. For the third characteristic point 2, 0, again, that one's going to stay the same because 0 times 1/3 is 0. And then we get 8, 2, because 6 times 1/3 is 2. Okay, I'm going to add one more question down here on the bottom. Because what happens if we have more than one translation left to right or up and down? What happens if we have a stretch or a compression? What happens if we have a combination of reflections in the same problem? So I'm going to put number 7 down here. Okay, so for number 7, we'll do -2 times p of x. So we have two transformations happening here. The first transformation we have is a reflection over the x-axis. And the second transformation we have is a stretch. So the y coordinate, is being multiplied by 2. So we perform the reflection first, and then we perform the dilation of just the y coordinates. So if we go back to our original characteristic points, a reflection over the x-axis keeps our x values the same and our y values become the opposite. So that reflection is going to give us -6, -3, 0, -9, 2, 0, and 8, -6. So the second part of our transformation is to multiply the y-coordinate by 2. It's going to give us a stretch, which means the distance of all the points from the x-axis is going to double. And so when we do that, the x value is staying the same. So it's -6, -6, 0 times -18. Remember, we're multiplying these times 2. This coordinate's not going to change. Ordered pair is not going to change, so we get 2, 0. And then for the last one, we get 8, -12. Because again, we're multiplying the y-coordinate by 2. And this is going to give us a vertical stretch. Again, the distance between the points between the x-axis is going to increase, it's going to double. Okay, so let's take a look at the multiple choice questions for tonight. If the function below were transformed using the rule f of x plus 2 minus 3, where would the vertex point end up? So if we're looking at this function here, and we applied this type of transformation, where would the vertex point end up? And keep in mind, the vertex is the highest or lowest point, and in this case, it's the lowest point because we have an upward facing parabola, so this is our vertex. So what will the coordinates of the vertex be after this translation, which is a horizontal shift 2 to the left and a vertical shift 3 down, or translation? And number 2, what transformations would happen if f of x were transformed to -2f x minus 3 plus 5. So we have 4 transformations here. We have the negative, we have the 2, we have the x minus 3 inside parentheses, and we have the plus 5. So there are 4 transformations that are happening, and again, the transformations begin from left to right. So this would be done first, then second, then we would worry about the 2 translations right here. Be sure to enter your answers on the Google form, and if you have any questions, please ask those as well. Have a good night.